Hello class 9. So this is the next chapter and we'll again be dividing this chapter into two separate topics. The first topic being atmospheric pressure and the second topic being winds. So the first topic, atmospheric pressure, is similar to the temperature and insulation chapter which we learned, wherein we learned the factors that affect temperature of a place, and we learned about how insulation, terrestrial radiation also influences the earth's the life that exists on earth. Same way, atmospheric pressure also plays a huge role in how climate changes from place to place. Just like our temperature, pressure also is equally important for climate to change from place to place. So as we always start, let's go through the syllabus. You know that all these, and in this slide you can see the atmosphere, the beginning two subtopics of composition and structure of atmosphere as well as insulation were completed in the previous classes, and we'll be discussing about the first half of the third subtopic, which is atmospheric pressure and winds. Especially we won't be discussing about winds, only atmospheric pressure, meaning and factors that affect atmospheric pressure, just like how we learnt about temperature and major pressure belts of the world. The rest we'll be discussing in the next. And topic number 5, pollution, as we already know, has already. So this picture clearly reminds you of a balloon, and you can see that the person who's holding the balloon is squeezing the balloon. So we know that balloons are always filled with air. Air has a tendency to occupy the shape of what container or where it is contained. Air doesn't have any particular shape, so if it is within a balloon, it takes the shape of the balloon, and it also has mass. But since we know that the air molecules are far away from each other, if we apply force, it can be compressed. That force or weight which we act on one side of air, which creates a pressure which will help the air to compress. That's the second picture which can be seen. Balloon which is not the same balloon but much more smaller, but it's still being compressed. So when compression takes place, actually pressure is being added. When we compress, we apply pressure, and this pressure makes the balloon to change its shape and the air moves away from the point of force. So the same thing happens on the surface of the earth as well. So on the lower layers there's more air molecules, and on the upper layers there are less air molecules. So the lowest layer will have so much of weight being pushed downward upper layers. So you can see that in this picture. The lower layer has so many air molecules, the upper layer has lesser air molecules. So the weight of the upper layers is actually acting down by giving a pressure, downward force pressure, always on the lower layers, and that is why there is air pressure always maximum near the surface and air pressure decreases with increase in altitude. Atmospheric pressure can be defined as the force per unit area exerted against a surface by weight of the air above the surface. The average atmospheric pressure of sea level is 1023.25 millibar. MB indicates millibar or 760 mm. This 760 mm, I'll clearly explain what does it mean in the coming slides. Unit, I've written here millibar, but there's also another unit called Pascal, PASCAL. So Pascal and kilopascal are also units which are used to measure pressure, but bars, millibars and kilobars are also used to measure pressure, atmospheric pressure, which is acting on the surface. So we can measure it using two major instruments. This is a normal barometer. We know that barometer is the instrument which is used to measure pressure. So this is a normal mercury barometer. So here you can see the same digits written, 760 mm. So this 760 mm is normal atmospheric pressure. When you keep an open container like this, what you see at the bottom, fill it with mercury, and you invert a test tube on top of it, you can see that the test tube will have a rise in mercury level to 760 millimeter. The mercury rises in the inverted tube The scale indicates the air pressure. There's a little bit vacuum on the top. And what is actually pushing this mercury into the test tube upward? The atmospheric pressure. So imagine you can see a blue arrow over there on the side. That is the force which is acting on the mercury, which is open towards the atmosphere. When you keep it in an open place, the air is touching the portion which is open, but the air is not touching the mercury inside the test tube. So wherever the air is touching, the blue arrow acts, or the blue arrow is the downward push that the air gives to the mercury, and that will push the mercury upward into the test tube, and that will rise up to 760 mm. So what will happen when we go to higher altitudes? When we go to higher altitudes, 760 mm will come down because the pressure is decreasing. When we go to lower altitudes or next or closer to the sea level, it comes up again high. It rises to the point of 760 mm. What about the second picture we see over here? This is called an aneroid barometer, or another type of barometer, where you can see a spiral structure, a pointer, a scale. This spiral structure is actually a balloon-like structure which is filled with vacuum inside. So an atmospheric pressure or any force that is acting downward from the air can easily compress this vacuum-like structure or this spiral structure downward. So when it presses downward, what will happen? The pointer will go upward. Always remember, when this vacuum-like spiral structure goes downward because of the atmospheric pressure, like the blue arrow which is indicated pointing down, when it pushes it downward, the pointer will obviously go upward, which means when there is more pressure exerted on this spiral structure, the pointer shows higher pressure because it is going upward. The same way, when we go to a lower pressure region, what happens is that the spiral structure rises up, which means the atmospheric pressure is less, so obviously the pointer will go down. Why do we use aneroid barometer? In certain places, extreme cold climates, if we go, the mercury becomes frozen. Or when certain places, when there is extremely hot climate, the mercury reacts in such a way that it doesn't rise or go down properly. So when temperature significantly affects the consistency of mercury, we are forced to a situation where we can't use this normal mercury barometer, and hence we move to. Okay, these are another important point. You can see two pictures over here. One picture indicates certain points which are noted with dots, and these points indicate different pressures. Okay, the name given to them is isobars. Iso meaning continuous or same. Bar, we know that millibar, kilobar, all are units of pressure. So bar, wherever you see bar, it means pressure. Iso means equal, bar means pressure. Continuous lines joining points of same atmospheric pressure. So for example, in Jammu and Kashmir, you can see an 845 and a 681. When you go towards Rajasthan, you can see 990, another 990, a 983. So all these are points where there is different atmospheric pressure. Just like contour lines, which we connect points of same altitude when you go through different regions, connecting points of same altitude, we get an imaginary line, and that line will actually tell the altitude of the whole place. Same way, if we measure pressures, different pressure points, and we connect the points of same pressure, we'll get continuous lines. These continuous lines are called isobars. Okay, so how these points, if we continuously join the points, we get continuous lines. Next one is pressure gradient. Pressure gradient is just like temperature gradient. When we go higher and higher and higher from the surface, away from the surface, we know that the temperature reduces. When we go deeper into the surface of the earth, the temperature increases. The same way, pressure also decreases and increases. Rate of change in atmospheric pressure between 2 points. So there's a point A and a point B. When we move from point A to B, there's a either increase or decrease in pressure. That difference is called pressure gradient. Gradient is steep if the isobars are closely spaced. The same like contours. We know that if contours are close to each other, 1, 2, 3, 4, 5 contour lines are very close to each other, it's a steep slope. And we know that if contours are far away from each other, it's a gentle slope. The same criteria applies here also. If the isobars are close to each other, it means that suddenly the isobar or the pressure level is changing. So there's a steep increase. But if the isobars are far away from each other, it takes quite a lot of time for isobars to increase or decrease, which means it's having gentle slope. And whenever there's a difference in pressure, it will create a wind or create a flow of air. So always remember, wind or a movement, horizontal movement of air is always moving from high pressure to low pressure. So when there's wind moving from high pressure to low pressure, remember that if the isobars are far away from each other, there is a slight difference in pressure. So small difference in pressure will create a slow wind. When there's a difference between high pressure and low pressure very quickly, which means the isobars are close to each other, the wind produced will be very fast. Gradient is gentle, the isobars are broadly spaced. Closely spaced isobars leads to sudden change in pressure within a small distance, resulting in fast winds. But broadly spaced isobars leads to gradual or slow change in pressure with long distance, resulting in slow, gentle. Just like temperature, there are many factors that affect pressure also. So we'll be discussing four major factors that affect pressure. In the atmospheric layers chapter, we discussed about how temperature increases, decreases with every layer, but pressure is constantly decreasing when we go upward. I hope you remember both the graphs, the temperature versus altitude graph and the pressure versus altitude graph. So this is again the pressure versus altitude graph. The altitude, when we go higher and higher, obviously automatically the pressure decreases. 1 centimeter of Hg, which means mercury, decrease for every 110 meter rise. So we already learned that at normal earth surface level, the mercury is at 760 millimeter, which is, in other words, 0.76 centimeter. So if we go 110 meters higher in altitude, there is a 1 centimeter decrease in mercury level, which means the pressure is decreasing. Air is thinner at higher altitudes and denser at lower altitudes. We saw the picture in the second slide where there were bigger molecules, more molecules of air at lower altitudes, but less molecules of air at higher altitudes. Few gas molecules at higher altitudes result in fewer molecular collisions and decrease air pressure. Air pressure, we know that because of the weight acted upon from the layers above on the layers below is air pressure. So if there is weight acted upon, or if there is any force acted upon on the lower layers, each molecule of air will hit with another molecule of air, causing molecular collisions. So when there is few gas molecules, obviously the collisions will be less and there's a decrease in air pressure. Number two, temperature. As temperature rises, we know that when we go higher and higher and higher, temperature goes down. But in places where there is high temperature, as temperature rises, it expands the air and it also rises. When we boil something, we see that warm air or water vapor rises up and cool air settles down. So when temperature rises, it expands the air and the air rises, causing a pulling in of nearby low pressure. The same concept of sea breeze and land breeze, which we have learnt earlier. When the warm air rises, there's an empty space or empty vacuum that is created, which has to be filled. And what will come and fill? The cooled land breeze will come and fill. Or if the warm air is rising in the land, the cool sea breeze will come and fill in it. So when warm air rises, it creates a low pressure and it's pulling all the air from the nearby surroundings from the high pressure regions to balance and create an equilibrium. So temperature increase decreases pressure. Temperature and pressure are always opposite to each other. Always remember that temperature, if there is an increase, pressure decreases. If temperature decreases or if it's a cold place, pressure increases. Okay, the next point is water vapor. Humid air with water displaces equal amount of dry air without any water. So we know from land breeze and sea breeze that sea breeze or the air that comes from the ocean has water vapor, but it displaces or takes the place of dry air of the equal amount. For example, 100 grams of dry air, because it's warm, the land is warm, is rising up. Only 100 grams of humid air from the ocean will fill it. Even though humid air has water vapor which is extra other than the oxygen, nitrogen and carbon dioxide, it can replace exactly equal amount of dry air, which means that the molecular weight of water should be lower than the molecular weight of air, and that's the case. The molecular weight of water, which means if you take 1 gram of water, the weight or the pressure, the force it exerts will be lesser than 1 gram of dry air. So 18 grams per molecule is the weight of is the molecular weight of water, and 29 grams per molecule is the molecular weight of air. So you can clearly see that water or air which is filled with water exerts a much more lesser pressure than air which does not have water. Okay, since because of this reason, humid air is considered to be lighter than dry air. The fourth point and the last point is rotation of the earth. We know that the earth rotates from west to east, that is why the sun appears to move from east to west. Most of the air at the poles, because the pole is very cold, there is high pressure there, it is moving towards the equatorial region, and most of the equatorial region which has very warm temperature creates a low pressure zone, and from that place receives a lot of air from the colder region. So this creates pressure belts or regions on the earth's surface which has different kinds of pressure. Here is a picture which clearly indicates different pressure belts. A is the region between A and B. You can see a blue line, that is a pressure belt. The region between B and the next big one, you can see another line where high HIGH is written. That is also a pressure belt. And on the equator you can see a green line which is also another pressure belt. So we'll be discussing about the pressure belts. There are 7 pressure belts. Okay. So this diagram would be a little bit tricky, but it is very simple for you to understand. I'll explain the diagram and then we'll go into all the 7 pressure belts. So first we know that we have maximum temperature on the equator. So equator has maximum temperature, and since we know the temperature and pressure are opposite, wherever there's high temperature we'll write low pressure, wherever there's low temperature we'll write high pressure. Okay, so on the equator we know there is high temperature, so we are writing low on either sides, and on the equator also, so we are writing low all over the equator. On the north pole and south pole we know that it's very cold. When it is very cold it will have high pressure, so we are writing high both on the north pole and on the south pole. So two regions, the north pole, south pole and the equator has been marked. So now there are 2 more regions in the northern hemisphere and 2 more regions in the southern hemisphere. The regions in the northern hemisphere are Arctic Circle and Tropic of Cancer. The regions in the southern hemisphere, Tropic of Capricorn and Antarctic Circle. So always near to a high pressure there will be a low pressure. Near to a low pressure there will be a high pressure. So near to the North Pole we have Arctic Circle. That latitude will have low pressure because it is near to a high pressure North Pole. The same way near to the equator we have Tropic of Cancer. So equator is low pressure, Arctic Circle is also low pressure. So in between we have a high pressure. The same pattern follows at the bottom also. Tropic of Capricorn is having high pressure and Antarctic Circle is having low pressure. So now when we look, we have low pressure belt in the center, which is on the equator. Then we have a high pressure belt on the Tropic of Cancer and Tropic of Capricorn. Then we have again 2 low pressure belts on the Arctic Circle and the Antarctic Circle. And we have 2 more high pressure belts on the North Pole and the South Pole. Now you have to understand that wherever there is low pressure, there is high temperature and it is receiving wind. Wherever there is high pressure, it means it is having cold temperature, it is giving wind. So if you look at the North Pole, if you look at the Tropic of Cancer, if you look at the Tropic of Capricorn and you look at the South Pole, all these regions are giving wind. But you look at the low pressure zones like Equator, Antarctic Circle and Arctic Circle, those lines are receiving winds or receiving the arrows. The arrow marks are pointing towards those lines, right? Okay. So another important factor is that there is another important force that acts on when the earth rotates, which is called Coriolis force. Coriolis. I'll repeat, Coriolis, Coriolis force. So this Coriolis force is when earth starts to rotate, everything on the northern hemisphere shifts towards the right or moves towards the right, and everything on the southern hemisphere moves towards the left. So that is why you have all these arrow marks either moving towards the right or moving towards the left. Okay, now we'll be moving into all the 7 pressure belts. Pressure belt number 1, equatorial low pressure belt. On the equator we have high temperature, so we have low pressure. It's been 0 to 5 degrees north and south. Vertical rays of the sun fall here. Because vertical rays of the sun, there is intense or very high heating. Because there's high temperature, there is a low pressure, and because of low pressure it receives a lot of wind. But since the pressure gradient or the change in pressure is not a sudden change but a gradual change, there is lack of breeze or very gentle breeze, and this gentle breeze or lack of breeze region is called doldrums. Number 2, there are two subtropical high pressure belts. Subtropical meaning close to the tropical region. We know torrid and tropical indicate the regions which are close to the equator. So just above and below the equator you can see two regions or two lines where the word high is written. We are discussing about those two regions. Two subtropical high pressure belts at 30° north and south. The ascending equatorial air descend here into two paths. So we know that on the equator the air rises up. The air rises up and it diverges into two paths, and it settles down when it reaches the Tropic of Cancer and the Tropic of Capricorn. So that is how it descends. After that, it can also be considered as two high pressure zones. These are also called Hawes latitudes. So the reason why it was called Hawes latitudes is that during earlier days, these are the regions where people used to travel in ships. And when they were traveling in ships, because the regions was having a huge effect or huge fast blowing wind, the ships would strike almost topple, and the ships would meet with an accident. So for that, if there were horses or if there are any animals which are present inside the ship, they would literally throw those animals into the ocean to survive such high powerful winds. So these are in, in situations that has happened in the past, and that is why it has also received the name Hawes latitudes. Okay, we'll be discussing about winds in the next session, and then you will understand the words of these winds. Trade winds towards equators and westerlies towards circumpolar regions originates here. There are two kinds of winds. You can see northeast trade winds and southeast trade winds. Those are winds which are generated or starting from the Tropic of Cancer and Tropic of Capricorn and going towards the equator. While there are another two winds which are prevailing westerlies, which are going from the Tropic of Cancer and from the Tropic of Capricorn towards the Arctic and Antarctic circle. So that is the point which is indicated here. The next low pressure belt is on the circumference or surrounding the polar region. So it's called circumpolar low pressure belt. There are two circumpolar low pressure belts, one on the northern hemisphere and one on the southern hemisphere. So initially we discussed about the equatorial low pressure belt, which is on the equator. Then there are two high pressure belts, subtropical high pressure belts on the Tropic of Cancer and on the Tropic of Capricorn. And then we already know that the poles have high pressures. So in between the Tropic of Cancer and the North Pole, and in between the Tropic of Capricorn and the South Pole, we have two low pressure belts on the Arctic Circle and on the Antarctic Circle. Here warm air rises and it diverges in both directions, and one part settles in the pole and the other part settles in the Tropic of Cancer or Capricorn. So what is different about the circumpolar low pressure belts? It lies between 60 and 70° north and south. The second point is that this is the belt where westerlies and easterlies meet. We already discussed what is westerlies. It is a wind which is starting from the high pressure belt, either in the Tropic of Cancer or the Tropic of Capricorn, and it is moving towards the poles. So this will not reach the poles, but it will end at the Arctic Circle or Antarctic Circle. In another word, it will end in this circumpolar low pressure belt. You can see the arrow marks of prevailing westerlies. It is starting at the Tropic of Cancer and ending in the Arctic Circle. And the other one, it is starting at the Tropic of Capricorn, ending in the Antarctic Circle. The same way, there are two winds which generate starting from the pole towards the circumpolar low pressure belts, and those are starting from east towards west, and hence they are called easterlies. While the other wind is from west to east, it's called westerlies. This is from east to west, and that is why it's called easterlies. So that is the main difference between the two. The next point states that warm air rises here. We already know that a low pressure belt is a region where there's high temperature, so warm air will obviously rise in this region. Violent storms are predominant in this region during winter. Because of the presence of warm air rising here, there are a lot of violent storms which are also seen. The last two is the polar high pressure belts. So one equatorial low pressure belt, two circumtropical, two subtropical high pressure belt, then two circumpolar low pressure belt, and finally two polar high pressure belts. So these are the extreme cold regions where there is extreme high pressure between 70 to 90 degree north and south. Extremely low pressure is extremely low temperature is created here, and high pressure, it is also called polar highs. These have permanent ice caps, and easterlies blowing towards the circumpolar belts start from these polar high pressure. Here's a video of all the seven belts and how the wind or how the belts start generating wind from one direction to the other. It's clearly described in the video which follows.
In this video, we shall learn about the various pressure belts and wind patterns that have developed on planet Earth. While understanding the basic concepts behind the development of pressure belts, we will not take into consideration the tilt of the axis and the influence of land-water distribution. Equator divides the globe into southern hemisphere and northern hemisphere, and equatorial belt extend up to 5 degree north and 5 degrees south. Equatorial region receives nearly vertical rays of the sun, and this heats up the air near the equator. When temperature increases, pressure decreases. So, along the equator we have low pressure, and we call this region as equatorial low pressure belt. The warm air starts rising up in the troposphere, and as the warm air is rising, the temperature drops. After rising up to a certain point, it stops rising upwards because it becomes cooler and it is obstructed by tropopause. So the air spreads out. The air starts moving in the southern and northern direction. As the air is moving, it becomes denser, and after a certain point, it sinks down to the surface. So, at around 30 degree north and south, we have sinking air. This sinking air is cool air, so it forms high pressure systems. These regions are called as subtropical high pressure belts because these regions lie outside the tropical region and at the same time adjoining the tropical region. The sinking air now moves towards north and south. So, along the equator, the warm air rises, spreads out, and cools and sinks down. In this way, it develops convectional currents. At the poles, the sun rays are very much inclined. So we have cold air that sinks. These regions are known as polar highs. In the northern hemisphere, the air moves towards the south, and in the southern hemisphere, the air moves towards north. At this point, we have air coming from north and south, So, at this point, the air converges and rises up. These regions are known as subpolar lows. So, at 60-degree latitudes, we have low pressure system because we have rising air. Along the equator, the air is rising because of convection, and at subpolar lows, we have rising air because of convergence. This rising air also spreads out, cools, and sinks. Same things happen in the southern hemisphere. On the surface of the earth, along the equator, the winds move from high pressure regions to low pressure regions. That is from subtropical highs to the equatorial low in the northern and southern hemisphere. These winds bend to the right in the northern hemisphere, and in the southern hemisphere, the winds bend to the left. And this is described as Coriolis effect. The winds bend to the right and left in the northern and southern hemisphere respectively, because the earth is spherical in shape and the earth rotates from west to east. In the same way, in between 30 and 60 degree north and south, the wind bends towards right and left in the northern and southern hemispheres respectively. Even at the polar region, the same phenomena can be seen.
That video clearly explained how each pressure belt is doing its particular kind of activity and the reason behind it. So the high pressure belts are the region where winds start, low pressure belts are the regions where winds end. And there are two major low pressure regions. One is the equatorial low pressure belt where you have maximum sunlight, so air rises up and it starts diverging on both directions. And then you have circumpolar low pressure just below the North Pole and just above the South Pole, where there is winds coming from the Tropic of Cancer and from the North Pole, and both these winds combine and rises. Same way in the southern hemisphere, there's a wind which is coming from the Tropic of Capricorn and another wind which is coming from the South Pole, and together it meets and it rises. So those two winds in the North Pole and South Pole converges and rises and causes rising air or warm air. So there are two low pressure belts on top and on the bottom, circumpolar low pressure belts, and another one is one major low pressure belt along the equator because of high sunlight. Then there are all the other remaining are high pressure belts, two on the poles and two on the Tropic of Cancer and Tropic of Capricorn. These are different positions of the sun, of the earth. I'm really sorry, of the earth. So you can see that during December and June, because of the inclination of the earth, the Tropic of Cancer is the region, is the point which is closest to the sun during winter. The Tropic of Capricorn is the closest to the sun during winter, and the Tropic of Cancer is the closest to the sun during summer. Okay, so that difference created will shift the pressure belts a little bit towards north and a little bit towards the south. Okay, we can understand that if the earth is straight, so all the equator, the Tropic of Capricorn, Tropic of Cancer, all will be straight. But since there is a slight inclination, the Tropic of Cancer, equator and Tropic of Capricorn is slightly inclined. When there is an inclination, at some point the Tropic of Cancer will be closest to the sun. That is during June 20, 21, 22, that period, which is called summer solstice. And there will be a time when the Tropic of Capricorn is closest to the sun, that is during December 20, 21, 22, which is called winter solstice. In between this summer solstice and winter solstice, there will be a time when the equator is exactly pointing at the sun. That is autumn equinox and the spring equinox, or also called vernal equinox. So these four positions we will be learning in chapter number 2 and 3. But you need to know these 4 positions for you to understand the next topic. So just now we learned that equator has maximum sunlight, and because of maximum sunlight air rises and it diverges, so you have an equatorial low pressure belt. But imagine if the earth is inclined. In summer solstice, Tropic of Cancer acts as the equator. In winter solstice, Tropic of Capricorn acts as the equator. So the whole pressure belt system will shift upward during summer solstice and it will shift downward during winter solstice. So that is the next topic, which is the last topic of this session, which is shifting of pressure belts. So you can see there's a shifting. The picture indicates that during March, which is an equinox time, a vernal equinox or spring equinox is when March takes. It's during the month of March. So that time all the equator, the Tropic of Cancer, Tropic of Capricorn, everything is at the same position because sun is directly pointing at the equator. But during June, it's summer solstice time, which means this the Tropic of Cancer is pointing towards the sun. So there is a shifting of 5 degrees of all the pressure belts in the upward direction. What about what will happen in December? The same thing will happen in the opposite way, where all the pressure belts go down 5 degrees. A 5-degree northward shifting of the pressure belts is seen during summer solstice, since during this time the sun is vertically over Tropic of Cancer. A 5-degree southward shifting of pressure belts is seen during winter solstice because it is vertically over, because the sun is vertically over Tropic of Capricorn. Both spring and autumn equinox, when the sun is directly facing the equator, that is the time when you have spring and autumn equinox. The pressure belts are equally distributed and there is no differences in